Okay, here we are, lesson number 90. Let's see if we can make this all work hunky-dory. This is systems of three equations. It's page 374. What you've done, if you look at the top of page 374, you've got a system of equations that you're all familiar with. You're given two equations in two variables, 3x plus 2y equals negative 4 and 2x minus 4y equals 8. And you've already learned how to solve problems like that. Let's put this one up here anyway. 3x plus 2y equals negative 4, and then we've got 2x minus 4y equals negative 8. Whoa. Okay. And at this point, what you've done is you took this top one and multiplied the entire thing times 2, so that this here would become a 4, and you could add it to this 4 and end up getting 0y, and then you could solve for x here, and makes life so much easier. I'm not going to go into all of the details for it because you already know how to do it. But let's just take that top equation. It ends up being 6x plus 4y equals negative 8, and we'll leave the bottom alone. Minus 4y equals negative 8, and then we add it. So we got 8x here, and this plus this is 0, so those go away, and negative 8 plus negative 8 is negative 16, so we get x equals negative 16 over 8, and our x equals negative 2. And then we take either one of these problems up here. Let's take the bottom one, 2x minus 4y equals negative 8. And what you did then is you plugged that negative 2 in here for x in order to find y. So we've got negative 4y equals negative 8. Whoa. So we've got negative 4 minus 4y equals negative 8. So we add that 4 to both sides. We get negative 8 plus 4 is negative 4. And then we can divide by negative 4, divide by negative 4. Hope I'm not going too fast. Like I say, this is old stuff for you, so you should be able to do this without any problem. And you get y equals 1. So my x value of negative 2 and my y value of 1, that right there is where those two lines, and when I say those two lines, I'm talking this line and this line. That's where they cross. Those are the two, that at this point right here, that's what those two problems have in common. They both, negative 2, if we put it in for x here, and if we put 1 in for y here, we would get the same answer as if we plugged it in for the x on the top and the y over here. So that's our solution there for that particular problem. What we're going to look at now is what are we going to do when we have three equations. So when I have x plus 2y plus z, whoa, plus, come on, plus z equals 4, and then here I have 2x minus y minus z equals 0, and then I have 2x minus 2y plus z, come on, plus z equals 1. So I got this system of equations here. Alright, like I've said before in the past, whenever you're solving these systems of equations, you can only do two problems at a time. Okay, you can't solve this whole thing by looking at all three of these and coming up with an answer. So what we're going to do is we're going to pick two of the problems up here. So let's just pick the top one and the middle one there, and let's just rewrite it over here. X plus 2y plus z equals 4, and 2x minus y minus z 0. Okay, so what we're trying to do here is we have two equations, but we have three variables. 1, 2, 3. We have an x, y, and a z. So what we have to try to do is get rid of one of those variables so that we can use systems of equations like we did over here and be able to solve this. So naturally, when we look at this, you can see right away that we have our z's right there that are the same. Different signs, but the same. So we can just add. And if we add, those z's will cancel out. Plus z, negative z gives us 0 z's. So we can just add this, and we get 3x plus 2y minus y is 1y. So we'll just put y equals 4 plus 0 is 4. So we get 3x plus y equals 4. It's exactly what we'd like to have, two variables, because I can do that. But the problem is that doesn't solve anything, because now in red I have one equation with two variables. So what I'm going to do is I'm going to look at two more problems here. So I'm going to look at these two. And the reason I picked those two is, again, because I have a negative z and a positive z, and I know the z's will cancel. So what we're trying is, in this problem, we eliminated the z's. So now in the next time I put two equations together with three variables, I also want to eliminate the z's, because if I can get rid of these z's, then I've got x's and y's only, and that's what I have over here is x's and y's only. So 2x plus 2x is 4x. Negative y minus 2y is negative 3y equals, equals 0 plus 1 is 1. So now I have an equation here, and I have an equation here, and they both only have x's and y's in them because I eliminated the z's. So that gives me 4x minus 3y equals 1. And down here I'm going to get my other equation, 3x plus y equals 4. Okay. So now I'm going to solve systems of equations just like I normally do. So I want to get rid of my y's, because that's a negative 3 and that's a 1. So I'm going to multiply this times 3. And that gives me, let me rewrite this here, 4x minus 3y equals 1. And distributing this 3, I get 9x plus 3y equals 12. So now I can add these, and I get 13 x equals 13, because these here went away. So that means x equals 1. And that's a good start. But now I have to go back and start plugging numbers in. So for instance, let's change color here and go to green maybe. Now let's stick with black. What I need to do is I need to take this 1 and I need to go up to an equation. Doesn't matter which one, but I want to pick an equation that has two variables so I can find my y. I mean, if I picked one of these problems up here, like if I would have picked this one, I plug 1 in and I've got a y and a z. Can't solve. So what I do is I pick an equation that has just two variables, and I put that 1 in for my x, and that allows me to solve for y. Minus 3y, y equals 1. Subtract 4 from both sides, and y equals negative 3 over negative 3, and that means y equals 1. Okay, so I got y equals 1 and x equals 1. Now, since I know two of the variables, I know that x is 1 and y is 1. Now I can grab one of these equations here that had three variables in it. Doesn't matter which one, and I can plug my 1 in for x and my 1 in for y. So let's erase some of this stuff I've got down here. And we'll take one of the problems from, this is one that was given to us in the original problem that had 3 variables in it. Let me get rid of this junk here. Alright, we don't need any of this stuff anymore. Okay, so, let's just take the top one. Let's take the x. Well, probably should get out of erase mode there. That would help. Okay, so we're going to take the x plus 2y plus z equals 4. Okay, doesn't matter which of these three I take. I just took the top one. So I'm going to put 1 in for x. I'm going to put 1 in for y. And I'm going to solve for z. Okay, so 1 plus 2 times 1 is 2 plus z, remember my z's have the little cross thingy through them, equals 4. So 3 plus z equals 4, and z then equals 4. 4 minus 3, so z equals 1. So in my final thing here, I get z equals 1. So x is 1, y is 1, and z is 1. Okay, we'll try another one in just a second. Okay, I'm going to do example 90.2 on page 375. Alright, what do we have here? 2x minus y plus 3z equals 9. Then I have x plus 2y plus z equals 8. And then my third one, I have x minus 2y plus z equals 0. Okay, so I have 3 problems here. Doesn't matter which one you start with, but you're just going to pick 2. And again, I'm gonna pick the top 2. So I'm going to do 2x minus y plus 3z equals 9. And I'm going to do x plus 2y plus z equals 8. Okay, so there's my system, my first 2 problems. So I need to get rid of one of the variables. It doesn't matter which variable you get rid of. You can get rid of the x's, the y's, or the z's. Doesn't really matter. I am going to go ahead and get rid of the y's. Okay, so in order to get rid of the y's, I'm going to have to multiply this whole top problem by 2, so that this negative y here becomes negative 2y, so that when I combine it with the second 2y here, they get a 0. So I get a 4x minus 2y plus 6z equals 18. Okay? And then here I get x plus 2y plus z, so nothing changed here, equals 8. So I'm going to add those. So I get 5x, my y's cancel because I've got a negative and a positive, and I get a plus 7z equals 26. Okay, so there I've got one equation here that I eliminated my z variable. So now I look back at the next 2 problems. Doesn't matter again which ones you take, just take 2 problems and get rid of the y, because you got rid of the y over here, you got to get rid of the y in the next one. So let's take x plus 2y plus z equals 8, and let's take x minus 2y plus z equals 0. Okay, this one's pretty easy because I already have a positive 2y and a negative 2y. So those will go away. So I have 2x plus 2z equals 8. Alright, so there's my other equation. Okay, so I got rid of the y's. So now I'm going to take my 2 equations. Let's just write them right here. And 2x plus 2z equals 8. Okay, can't add them though, because I don't have common numbers there. I have 5x plus 7z, and I have a 2x plus 2z equals 8. So I'm going to have to figure some things out. I am gonna, let's just eliminate the x's. So I need to be able to make the coefficient of this x something other than a 5, and the coefficient of this x something other than a 2. And it's got to be the same number, so it's got to be a number that both 2 and 5 go into. So in this case, it would be 10. So in order for this to be a 10, I'm going to multiply that by 2. In order for this to be a 10, I'm going to have to multiply that times 8. Okay? So that gives me 10x plus 14z equals 52. And then this is going to give me 10x plus 10z equals 40. Okay, so I have two positive numbers here. If I add them together, I'm not going to get 0. So what I'm going to do is I'm going to subtract. That'll give me 0. So 10x minus 10x is 0. 14 minus 10x, 14z minus 10z is 4z. And 52 minus 40 equals 12. Okay, some people, what they'll do is up here where I multiply by 5, they'll multiply by negative 5, and that'll give you a negative 10 here already, and then you can add them. But either way works. So that gives me a z of 3. Okay. So, once I find out that my z is 3, I can take one of my other equations. So, for example, let's say that I take this equation right here, okay, and I plug a 3 in for z. 2x plus 2 times 3 equals 8. So that gives me 2x plus 6 equals 8. Subtract 6 from both sides, and x equals 1. Okay, so now I have a z value, and I have a x value. Now I can go up here again and grab any one of these equations, plug 1 in for x and 3 in for z, and solve for y. So I'm going to take the bottom one this time, because that's just got an x by itself and a z by itself, so it makes things a little bit easier. So instead of an x, I'm going to put 1 and 2y, and instead of a z, I'm going to put 3. So 1 plus 3 is 4, minus 2y equals 0, negative 2y equals negative 4. Divide by negative 2, and y equals positive 2. Okay, so that's all there is to that. So, just real quick in a nutshell, you're going to take two of your equations, doesn't matter which one, and start eliminating a variable. Then take the next two and eliminate the same variable. Then use systems of equations like we did here to solve for one of the variables. Take that one variable, plug it in to an equation that has two variables so that you can find this variable. Once you do that, you've got two variables found, this one and this one. Take those and plug them in right here into one of the equations with three variables to find the third variable, and you be done.